Okay, today is reviewing, actually and including new material on 1 over f of x. This is the new thing for today, how to take 1 over a function. What we learned on Wednesday that I'm going to review with you first is how to take a function and then either take the absolute value of it, like that, or take the absolute value of it, like that. Okay, so a real quick review of what we learned Wednesday. If you have a function, and let's say it looked like this, a big check mark kind of. I'll make this curve a little bit more so it's sort of like a big check mark, like you got this one right on the test, or you got this done on your list, or whatever. The question is, what would happen to this f of x if we absolute valued all the way around it like this? When I do this kind, am I absolute valuing its x's or its y's? It's y's. Because think about it, f of x is y, isn't it? So I'm pretty much absolute valuing the y's. I'd like you, if you already watched the video, you should kind of remember this. If you absolute value the y's, tell me what the new function graph would look like. Please use 2 colors. The first color, I don't care what you used for your f of x, your parent one. But please make the second one in blue. What would the new function look like when you absolute value around the outside of it? I'll pause for a second. Let me give that a try. Okay, so here's how this one works. You should be thinking to yourself, what is the absolute value going around the y's? Therefore, y's that were negative are going to become positive. So these are the area where the y's were negative down here. So that area has to become positive. So my new answer is this stays the same. The next part, it goes up like this, and then this part stays the same. So your final answer does not have this in it at all. And it looks sort of like a W with a really long tail. Raise your hand if you had that one right. Okay, good. Now, let's see if you can take the original, which is the red check mark, and do that to it. Absolute valuing the x's. Now, if you didn't watch the video, this would probably be a tough part for you. And I would have a prediction on what you would think, but usually that's wrong. We'll see. Give it your best shot, compare with the person next to you. And if you weren't here and they were, maybe I can tell you what's going on here. I'll pause while you try that one. Okay, let's see if you're on the right track. When you absolute value the x's, that's kind of like it's on the inside. Do you remember that little way to remember it, where it's horizontal on the inside and vertical on the outside? Hi-vo. Does that ring a bell? This is on the inside, right? So it's a horizontal kind of change. So from left to right, this area stays the same because all the x's in that area were positive. When we absolute value them, it doesn't do anything. And so therefore, it's this left side that disappears. And if you didn't ever watch the video, you probably just thought that that is the answer. Oh, that's weird. It jumped over when I tried to erase that. I remember that happening last hour too, so I'm going to just scribble out my answer like this and say that part doesn't exist anymore. Then what you do is think about it as if I were to put in like a -3 or whatever that is, it's going to think when I put in the -3 that I put in a +3 because the absolute value happens first. And then I go over here to +3 and go up and say, oh, so the answer is like 5. So the answer for this one will be 5. And it'll end up being a perfect reflection like that. My final answer is this part, and that part never changed. So basically, it's a great big V. Or a seagull flying, if you like to think of it that way. Raise your hand if you had that one right. All right, good. So that's a review of that topic. Now what we have to do is take something like this. I'm going to give you a tough one to start with because I think it's good for you. A function that goes like this. And I want you to think about, if this is f of x, what would, in blue, 1 over f of x look like? A lot of people just think it's an up-down flip because 1 over something kind of flips it. Like if you have 3 and you take 1 over that, it becomes 1/3. But it doesn't. It's not just an up-down reflection. Definitely not. It gets really strange, in fact. Maybe you don't know how the whole thing looks. I wouldn't have. But if I was challenged to find 1 over f of x at just 1 point, I could have done it. Let's see if you can. You might not know for sure what that point is, so I'll tell you that that's like 7, 5. What would 1 over f of x be at that point? And if you just keep doing that for all the other points on the graph, you can figure out what the new graph looks like. Just do it point by point. Just take 7, 5 and say, what the heck would 1 over f of x be? Now think about it. 1 over f of x. Am I messing with the x's or am I messing with the y's? The y's, because f of x is y, right? Who knows what the new point that correlates with the green one that I did? Who knows what that new point is? Only one person, seriously? 3 people, 4 people think they know. What do you think it is? Why did you leave the first coordinate of it as a 7? Yeah, it's f of x that I'm messing with, which is the y. So instead of the 5, you gave it 1/5. You are so right. 7, 1/5 is my new point. I'll do it in blue to match with this blue motif I have going here. 7, 1/5 over 7 up 1/5. That's up a very small amount. So, like right about there. Do you get you could do that for every single point on this graph? All right, so let's do it for another point. Let's do it for like, let's say this is 9, 8. Since it's on the original graph, I should have really made it green. So I'm going to go do that. Green. Do you get that 9, 8 would turn into 9, 1/8? Okay, so then my new point here is at 9, 1/8. Well, that's even lower than 1/5. Let's take a more unusual spot, like let's say this spot. It's really, really low. So let's say that it's like 1/2. It's only up 1/2. So let's say it's at like 2, 1/2. That's about right there. Figure out what its new point would be. Again, I wish I had made it green, so I'll cheat and change it to green. Go with that color green. Do you get that the x isn't even involved in this? The x stays exactly the same. Uh-oh, undo that. There we go. The x stays exactly the same. It's just the y that gets 1 over. Okay, so then my new point would be in blue. I guess my new points I was doing in blue here. Should have made that blue. Is 2, what's 1 over 1/2? 2. Do you get when this thing gets really small that my point gets bigger and bigger and bigger? Let's explore that for a second. Because everybody has this concept that when you divide by something, it gets smaller. Not if you divide by what? A fraction. What if I divide by 1/100th? What's the answer to that? 100. Get how really small turns into really big? Okay, so when you're doing inverses, you say, well, if this is really small, then this one should be much bigger. As this gets closer and closer to 0, this is going to get taller. All right. What about at 0? What about this spot right here, the origin, where it looks like it's hitting? It's hitting at 0. Then it's 1 over 0, which is equal to no such thing. You can't have an answer there. And therefore, wherever my original function touches 0, then I have 1 over 0, which is an asymptote line. So if I'm drawing this in blue, here comes my asymptote line right down there. And where's there another spot like that? Point with your finger. Over to the left. This spot right there where it touches 0 is another spot where there must be an asymptote. Because at that moment, f of x is 0, and therefore my new function is at 1 over 0. All right. What's another important thing besides figuring out where f of x was 0, because that's going to turn into 1 over 0, which is impossible. What's another kind of key moment when f of x is equal to, yes, if f of x is a negative number, then my answer will have to come out negative. That's true. There's another key spot. I could just tell you, but come on, somebody figure this out. F of x being 0 is a big deal. F of x being something else is also a big deal. I'll give you a hint. It's the only place on the graph where the red graph and the blue graph will have to touch each other. They will be exactly the same thing, only at this spot. Peter. When f of x is 1, you are correct. So is that where x is 1? Where y is 1? Yes. Would you agree that there are 3 spots on my red graph where y would be 1, approximately? At, let's say this is about 1 high, you know, the distance here is about 1. Okay. So at that spot, and that spot, and that spot, those are 3 spots where f of x is 1. And when you put in a 1, it becomes 1 over 1, which is 1. So those are the only spots where the graph will stay exactly the same as it was. So since I'm doing my new graph in blue, I'll have to hit here, I'll have to hit there, and I'll have to hit there. These get messy, don't they? This will be your toughest thing to know by Thursday. It's the 1 over f of x. Inverse of a function. Once you get the hang of it, though, it's not that bad. Can you connect the dots? Because if you get a few dots and you know which direction it's generally heading, if you can connect the dots, you'll be fine. One more thing. Do you know about asymptotes? That things, functions that get close to the asymptote, they get closer and closer to it, but they never actually touch it? Okay. So then, look at, I've made this point here, this point here, this point here, this point here, and then if I'm going to have to get closer and closer and never touch it, do you get, as this graph gets to be really, really small numbers in here, my graph has to be really, really big numbers here, so it's going to be like this. And I have to go through this point, and now that could be a little tougher to figure out, like, should I go like this then? Or should I go the opposite way, and maybe it's like this then? It's not either one of those things. It's close to one of those things. I need a few more points on that one to kind of tell me where to go. Who can tell me another important point? Besides where it equals 1 and where it equals 0, do you remember us talking about graphs and talking about mins and maxes? Do you see anything up here? A local max. Very good. This local maximum right here. Let's say I could tell you that that spot right there was at -3, 3. Could you make me a new point for that? You get how the x wouldn't change and the y would, okay? Got the new point for it yet? Write it down, compare it with the kid next to you. See if you know what the right new point is for that. That's all I'm asking. I get you might be confused about everything else, but just tell me what's the new point for -3, 3. Don't say it. Compare with the kid next to you. Write it on your iPad. I'll pause for a second while you try that. Okay, I'm back. So what you should have figured out with that other person was that the x doesn't change in your new point, and therefore it's got to be -3, something. And the y is not 3 anymore. It's 1 over that, so 1/3. So -3, 1/3. Do you get now that this point, and this point have to be on my graph, and therefore I can kind of tell where it goes? Remember how it has to get closer and closer to the asymptote? So it must go like this. The only reason that one of them that I did before wasn't right is because I purposely, when I was doing my does it go here thing, I went down below. What would that mean? That meant that I went negative. There's no way for positive numbers, when you take 1 over them, to turn into negative numbers. I can't go down below that line. Would you, if you really understand this, that you're taking 1 over the y values, you can make up numbers if anything you want for this. You can say, oh, I think that's about -7, -2. You can pick anything you want to and then make the new point for that. So tell me, on the left end of this function, this is the red one, draw in blue where you think that should be when you're doing the inverse. Remember, you can just pick points and do inverses of them and keep graphing them until you get the idea. And then please compare with the person that I paired you with for today and see if your left side of your graph, the blue thing you're making, the inverse, is in the same spot as theirs. I'll give you a hint. It'll have to go through -1. Just like 1 was really important, we hit that here and here and here. The -1 is really important. Let's say that this right here is where it's at y is -1. Well, then that's got to be a spot on your new graph because 1 over -1 is -1. Okay, compare with the kid next to you and see if you do this left end correctly. Okay, I told you it has to go through this spot, so I'm going to go through that spot. And I have to get closer and closer to the asymptote line. And do you get all of these points here are all negative for y. Y is negative on every single case. All of these spots are negative, so therefore 1 over a negative has to stay negative. Therefore, I cannot go up into this zone up here because those are positives. Therefore, it should be like that. And it doesn't ever cross 0. Why? Because it never touched 0. If it had touched 0, there'd been an asymptote there anyway. And 1 over 0 would make an asymptote. It's just 1 over a really small, a really big negative number, like down here, is making your answers be like getting closer and closer to 0. Okay, so there's a weird dynamic in these where you've got to understand, if I have a graph that's kind of doing this, then what's its inverse going to do? If this thing is totally rising as you go from left to right, it's getting bigger and bigger, then what's 1 over that going to do? Get smaller and smaller. Do you get that it generally if we should pick points. Do you get how 1's a big deal? Let's say that's 1. Take that one and tell me what the inverse of it is. I mean, not just that point. I mean, the whole thing. Graph the inverse of the blue graph. If you need to, pick points on it and say, okay, I'm going to say that's 8, 3. So if you go completely brain dead on the day of the test, all you have to do is pick points and do it 1 point at a time. Say, okay, well, I'm going to say this is 1, 1. No, I'm going to say it's 3, 1. Sorry. Then, what's my new point going to be? If I'm graphing 1 over x, I will do it in green. 1 over f of x, sorry. Then, it's got to be 3, 1. Oh, it's the same point. That spot stays the same. And then as this one gets bigger and bigger on the blue line here, this gets bigger and bigger and bigger, the other one has to get smaller and smaller and smaller. Raise your hand if you did that part right. Okay, good. And if this one we can assume must be following and getting closer and closer this way, right? As it gets closer and closer to 0, this other one's going to get closer and closer to infinity. Because 1 over, like 1/100th, is 100. What's another spot I could have known for sure? You pick any spot you want. Let's say I want to pick this spot, and I'm going to say that's 8, 3. Then my new point should be 8, what? 1/3. So it's over 8 and only up 1/3. So yeah, I guess I'm doing it right. Okay, final test. See if you would get this one right. That is not exactly vertical, so I should let it slowly decrease like that. There we go. Graph the inverse of the black graph. Remember, you can make up points. Like at some point, I would probably say, okay, I think that's going to be about this. You can make up your own point for what you think that is. 7, 6, whatever. Little help. What did I say were important spots? Somebody remind me. Yes? Where the original function is 1, I agree. I'm going to say that this is where the original function was 1. And so is this, and so is that. Raise your hand if you guys had those spots identified. Okay, good. Why are those important? Because that's where f of x is 1, and therefore the new graph would be 1 over 1, which is the same spot. Your new graph has to go through those spots. What else was an important spot? Yes, sir? The local max and the local mins, but let's talk about the local max. What did you say that spot was? 5. Sounds good. Then my new point would be 5, 1/6 over 5 up 1/6 pretty low. I've got to go through. Oh, I should make it red because I've been going with a red theme for my new graph here. Okay. I don't see any asymptotes. Would it be handy to have my asymptotes in there? Probably would be smart. Where do I put the asymptotes in? Where what's 0? Where y is 0 on the original function. Okay, on my original function, y is 0 right here. So I'm going to say there's an asymptote line right through there. And right there. So 1 over 0 is undefined, and so therefore there must be an asymptote line right there. Okay. And now I just have to connect the dots and mind the asymptotes. The asymptotes are sort of like an electric fence. Don't want to touch those. You might have a game where you get closer and closer, but you should never touch it. There you go. I'm guessing farm kids have all touched the electric fence. Have any of you touched the electric fence? Have you? What was it like? What I hear is that when it is in its pulse mode, it pulses, by the way. It's not a constant stream of electric, because if you, like, by accident grab a hold of it, why do they need to pulse it? So that you can let go. Because otherwise, when you grab a hold of something where there's an electric current, it causes your muscles to clamp, and you can therefore be stuck to that thing and not be able to let it go. My dad had a great story about this in my basement. He was down there working on some project, and he had an electric drill in his left hand, and he reached over and grabbed a lamp in his right hand, and the electric drill was connected to the wall, and it would have all been fine, except there was a short in the lamp, so that the lamp post was live, and that connected the circuit. So he was in the middle of the electric current, and he was getting electrocuted, and he knew it. And he also knew that he wasn't going to be able to let go with either hand, because he was gripping with his right and gripping with his left. What do you do?
Pull it out.
You don't just die. No, he chose to live.
Pull it out of the wall.
You got it. He pulled it out of the wall. Now, he wasn't like just, super calm about it and just like, okay, I'm going to walk until the cord pulls out of the wall. What he did is he thrashed his arms around like a crazy man and like stumbled across the room, and finally the cord unplugged and he lived. But had he not been able to get it unplugged, he would have electrocuted right there. So anyway, those are electric fences, the asymptote lines. You don't want to touch them. All right, this guy, I know you know that it has to go through this, but is it like going down like this? One of the rules, I'm breaking one of the rules. What rule am I breaking by doing that? I went into the negatives. Can something that's positive, when you take 1 over it, turn into negative? No. So I can't go into the negatives at all, because this little section right here, the original function is all positive numbers, so it has to stay positive. Therefore, now, how about that? What do you think of that? You agree? Okay, good. And then the last thing, this. Well, again, if I was lost, like, oh, I can't remember what this should do. Remember that -1 would be an important spot right there. And it goes like that. Okay, wait, I know you want to leave, but you need to know what your assignment is. There's only 2 problems. You need to draw yourself a parabola, which looks like this. And I want you to do, listen, don't move. I want you to do absolute value of the function on the outside, absolute value of the function on the inside, and then take a wild guess what the third part is. 1 over the function. The only other thing is, do those same exact things to a big Minnetonka M. Like that. And tell me what all 3 things are for both. That's only 6 homework problems. I kept it short. You get it done. That's all I got for you for today.
Thank you.